Can you see the screen?
Yes.
So today we are going to start our third lesson on electrochemistry. So till now we have discussed about redox reaction and electrochemical cell, galvanic cell, cell reactions we have discussed, cell representation we have discussed, and I told you that how to represent cell, like there will be anode will be there, and in anode how to represent anode, like the electrode will be there, then single line, then the electrolyte, and then solid bridge is there, and then again electrolyte, and then electrode, right? And that is for cathode. This is for cathode. And in anode, what reaction is there? Oxidation, right? And cathode, what reaction? Reduction. Clear? Next, we talk about solid bridge. What is solid bridge? Why we need that? Especially the characteristics of solid bridge. Okay, liquid junction potential (LGP). That's important. Okay, I told you about that. Now, electrode potential E naught. How to calculate E naught? Oxidation potential. Okay, oxidation potential, reduction potential. Mostly we'll talk about reduction potential only. Based on reduction potential, how to calculate that? We know standard hydrogen electrode. Okay, what is the reduction potential of standard hydrogen electrode? What is the reduction potential of standard hydrogen electrode? L. What is the reduction potential of standard hydrogen electrode? Zero only. Based on that, it is the reference. You are not reading. Is it completed? All of this completed, right? Yes or no?
Yes, sir.
So, see, this is not the thing, right? Okay. Before class, you have to read at least once or twice. Otherwise, how can you this see whole grade 12? I am telling you that you have to do like that, completely connected. All the things are connected. So now only it's okay. But chapter wise, all the things are connected, as well as in organic chemistry, all chapters are connected. So if you are not reading before class, or if you are not revising the things going on, you are not you will not understood the next topic. Understood? Next, we'll learn about electrochemical series. Okay, electrochemical series up to down. Okay, positive to negative. Sorry, negative to positive values. Negative means more, negative means good. More negative means good. Reducing agent, right? Yes or no?
Yes.
More negative means good. Reducing agent. Correct. Reducing agent means who keeps electron easily. Okay, so more negative means more good reducing agent, more positive means good oxidizing agent. So if we talk about highest one is lithium. Okay, and then finally going down and down, and then hydrogen will come, and downside of hydrogen, uh, all the copper, silver, and all. In grade 10, you learn about reactivity series similar to like that, but here in the values you need to remember some of them. Okay, next we learn about delta G naught is equals to NF minus NF E naught cell. Okay, and we talked about EMF. Okay, electromotive force, intensive, and how to calculate all the things we did, right? Yes or no? I told you when n total. Okay, hello.
Yes, sir.
Yeah, when n value, number of electron of total will be is equals to n1 and n2, means in oxidation and in reduction, then only we can write that E naught cell is equals to E of cathode minus E of anode, right? If not, then just multiply it with the n value. If n value is not same, then just multiply it with the n value. N total is equals to n1 of the cathode, n2, then plus will come, plus n2 will of cathode. Okay.
Yes.
So today we are going to start our most important topic, that is called Nernst equation. Nernst equation. I think in school you did that. Okay. we'll do again. So what is Nernst equation? Okay, scientist Nernst was there. He told that you calculated E naught. Okay, E naught means standard electron, standard EMF. Okay, standard electromotive force or standard electrode potential. Okay, but that E naught you calculated at 298 Kelvin. Okay, at 1 bar pressure you calculated, standard condition you calculate. But actually when you are using the batteries, okay, or when you are using any cell in your home or anything you are using, in that case it is not 298 Kelvin or 1 bar pressure. It will be changed, the pressure, the conditions will change, or you are doing a reaction, conditions can be changed, right? For example, this reactions is going on A to B, right? Now this reaction can be done in any condition, any temperature, any pressure, right? Yes or no? So for that we need to check the what is the electrode potential. Okay, so that is not E naught cell, that will be changed. Now let's suppose a reaction is in equilibrium, A to B, they are in equilibrium. Let's see how many of you can tell that what is the like reaction quotient or K equilibrium. Let's say what is the K equilibrium reaction constant, equilibrium constant of this reaction. How to write equilibrium constant? V by product by reactant. Product by reactant, but not product by reactant. Concentration of the product to the power its coefficient divided by concentration of the reactant to the power its coefficient. Okay, this is K equilibrium. Now what do you mean by K equilibrium? K equilibrium is a special case. Remember, K equilibrium means this concentration whatever is in equilibrium. Okay, understood? This concentration means whatever is in equilibrium, but actually anytime concentration we need. So for any time concentration we need, that is called reaction quotient. Instead of K equilibrium, that is known as reaction quotient. So reaction quotient is equals to same thing, concentration of B to the power B, concentration of A to the power A at any time. Okay, it's not like at equilibrium. If it is at equilibrium, we call it K equilibrium. If it is not at equilibrium, we call it reaction quotient. Okay, we call it reaction quotient. Understood? Yes, sir. This thing understood, everyone? Tell. Any doubt, ask me. Okay, don't be hesitant. Tell. This thing understood? Yes, sir.
Yes, sir.
Now, from the previous, you know that delta G is equals to delta G naught plus RT ln Q. I told you this. Delta G equal to delta G naught plus RT ln Q. Now delta G is equals to, can I write NFE, and delta G naught equal to, can I write NFE naught for this reaction. Okay, plus RT. Okay, acha, if I change ln to log, okay, ln Q to log Q. So what will we have to do? 2.3, we have to multiply it with 2.303 or 2.3 log K. Yes or no? Log Q. Log Q. So from here we can write that 2.3 RT log Q. Clear? Now all the sides, both the sides divide with minus NF. So if you divide with minus NF, so this will be E equal to E naught minus, it will become minus 2.3 RT by NF. Yes or no? And log Q. Now log Q means concentration of B to the power B divided by concentration of A to the power A. Achha, B to the power B means concentration of product, and A to the power A means concentration of reactant. Clear? So see, listen, by seeing a cell, you just first thing you have to do, you have to write the cell reaction. If you do that, your 50% work done. Okay. Even by practice, you will see that without writing the cell reaction, you can write this easily. I'll tell how to do. So E cell, EMF of the cell will be equal to E naught cell minus 2.3 RT by NF log this by this. Understood this thing? Yes, sir. Now, if T temperature is 298 Kelvin, let's suppose if temperature is 298 Kelvin, pressure can be anything, volume can be anything, anything. So if I put the values, so E cell as it is, E naught cell as it is, so 2.3 R value is 8.314, you know, 8.314. T value 298 Kelvin or 25 degrees Celsius. N value is depend on the reaction to reaction, and F value last class I told you 96500. Yes or no? Yes, sir. So log of concentration of B to the power B divided by concentration of A to the power A. If we calculate all these things, finally we will get that E cell is equals to E naught cell minus 0.059 divided by N log of concentration of B to the power B and concentration A to the power A. Okay. Okay. Yes. Now for better calculation, don't use 0.5059 for calculation purpose. When you are writing in your board exam, always write 0.059. Okay. For calculation purpose, you can write that E cell is equals to E naught cell. Okay. Minus 0.06 by N log of product by reactant. Clear? Clear or not? Yes. Now, if I ask you some questions you will do, it will be easy. More the practice you will do, it will become easy. So calculate E naught cell. Okay. Calculate E cell value. E cell. First, E of Mg2 plus. Mg2 plus. Concentration given 10 to the power minus 5 molar. 10 to the power minus 5 molar. And E naught cell value given, 2.35 volt. Okay, 2.35 volt. Now calculate E of Mg to Mg2 plus. Calculate. So one I am doing. Okay, rest of you will do. Listen, whenever this kind of question given, first you have to see what is the cell written. Cell is written Mg to Mg2 plus. So what is the reaction? Mg to Mg2 plus. Yes or no? Plus 2 electron. Clear? Yes or no? Now magnesium is solid and magnesium 2 plus is aqueous. And for this reaction, E naught cell value given. For this reaction, E naught cell value given 2.35 volt. Okay, now by this reaction, you can find out that N value is 2 because 2 electron is used here. Clear? Now we know that E of Mg to Mg2 plus is equals to E naught cell minus 0.059 by N value. What is the N value? 0.059 by N. So 2. Now log of product. What is the product? This is the product. So the reaction is balanced, no issue. So this is the product. So product concentration Mg2 plus concentration divided by the concentration of Mg. Now you will say, sir, Mg2 plus concentration given 10 power minus 5. Why Mg concentration not given? See, any pure solid, remember, any pure solid or pure liquid, pure solid, last chapter you understood, na? Last chapter, liquid solution, or when you make solution, then we will talk about concentration. But if it is pure, then concentration not there. So is not there. So pure solid or pure liquid is 1. Understood? Concentration of pure solid and pure liquid is 1. Only the concentration we will take when it is aqueous, or and in that case concentration we will take. And if it is gaseous, pure gaseous, then we will take partial pressure. Okay, we will take partial pressure. Understood this thing? Yes. So magnesium, this value 1. So E naught value is equals to 2.35 minus 0.059 by 2 log of how much? 10 power minus 5. 10 power minus. Achha, you know log? Do you know log?
Yes.
You know log, everyone. If you don't know, I'll discuss again. Don't worry. So simple thing, remember, log 10 base 10 power x is equals to x. Okay, so if log 1 is there, that means 10 power 0 is 1, so 0. If log 10 is there, 10 power 1 is 10, so 1. Log 100 is there, so 2. Similarly, log 10 power minus 12 is there, so 12. Understood this thing? But some values are also there, like log 2 values, log 3 value, that you need to understood. Okay. Sir, will it not be minus 12? It's minus 12. Sorry. Okay, so this is minus 12. Understood? Now here, so here what will be the value? So 2.35, already minus is there, so minus 0.03 multiplied with minus 5. Yes or no? Yes. So when you calculate all of them, you will get 2.5 volt. Clear? Yes, sir.
Yes.
Okay. Understood? Any doubt? Kirti? Any doubt? Aditya? Understood? Yes or no?
Understood, sir.
Okay. Next, like one more question. Let's see who can tell first. Question is that you have to find out E of Cl2, okay, whose concentration given 0.1 bar, and Cl minus 10 power minus 5 molar, okay, and E naught cell value given, 1.5 volt. Go ahead. Tell.
Sir, is it minus 1.55?
Wrong. So simply, what is the reaction? Cl2 to Cl minus, yes or no? Okay, so Cl2 to Cl minus, 0 to 1. So what is this? Reduction or oxidation? Reduction. So plus 2 electron, yes or no? Plus 2 electron. And you have to balance this 2. Okay.
Yes, sir.
Clear this thing? Now,
Yes.
E is equals to E naught. E naught value 1.5. So 1.5 minus 0.06 divided by 2 log product. This is the product, but product square, right? So 10 power minus 5 square. Clear? Yes or no?
Yes, sir.
Divided by 10 power minus 1. Understood? 0.1 means 10 power minus 1. Yes or no? So is
Yes.
equals to 1.5 minus, this is 0.03. Okay, so this will become 9. Understood? This will become 9 because 10 to the power minus 10 divided by 10 power minus 1. So 10 power minus 9, log of 10 power minus 9 is 9. So then you calculate whatever 1.5 minus 0.27. Okay. So whatever the value you will get, 1.23. Clear? Clear or not?
Yes, sir.
Understood how to do? Tell me, what is the problem?
Understood.
What is the problem, Ashmita and all? What is the problem? Tell.
The reaction quotient, that thing I forgot, sir. That stoichiometric coefficient.
Okay. Next, Fe3 plus 10 power minus 3 molar and Fe2 plus Fe3 plus 2 Fe2 plus 10 power minus 1 molar. E naught value given minus 0.5 volt. Find out E value. Go ahead.
Minus 0.17.
Hmm? How?
How means the reaction is Fe3 plus 1 electron gives Fe2 plus.
Fe3 plus 1 electron gives Fe2 plus, right?
Yes, sir.
So E is equals to minus 0.5 minus 0.06 by 1, right? Log product by reactant. So product is 10 power minus 2. Sorry, product is 10 power minus 1 divided by reactant is 10 power minus 3. Clear? So minus 0.5 minus 0.06. This will be 10 power 2 log 10 power 2. So is equals to minus 0.5 minus 0.12. Here is equals to minus 0.62. Here.
Yes, sir.
So how we are getting that? What is the problem? What is the mistake you did? Hmm? Now,
Subtraction.
so now calculate for this. Go ahead.
Sir, you didn't give E naught value.
I didn't give in out value. Given. Check. Check properly. It is written. Check properly. Inode value written. What is the inode value for this cell? Hydrogen to H plus.
0.
So
0. Okay, sir. So 0.088.
0.088. Okay, let's see. So E is equals to E naught is 0. Okay, minus 0.06 divided by 2. Yes or no? Like H2 to H plus. Yes or no? So how many electron it will leave? 2H plus. So plus 2 electron, right? So 0.06 by 2. Okay, log concentration of H plus square. So concentration of H plus is 10 power minus 2 square divided by concentration of H2 0.1. So minus 0.03 log of 10 power minus 4 by 10 power minus 1. So 10 power minus 3. Yes or no? So minus 0.09. Clear or not? Tell what is the problem? Where you did mistake?
Sir, I took the 0.059.
Even though if you are taking 0.059, it will be close to 0.09 only.
Yes, sir, 0.80.
Okay, okay. Okay, okay.
Sir, is it not positive, sir?
Huh?
Is it not a positive value?
Value will become positive. Okay. Value will become positive. Okay. Final value because minus minus will become positive. Okay. Next. Next. For a cell, galvanic cell, how to calculate? These are at electrodes. Okay. These are half cell we calculate. But for a galvanic cell, how to calculate? So let's suppose consider a galvanic cell. Consider a galvanic cell. Galvanic cell. Cell is given zinc plus H plus aqueous gives zinc 2 plus aqueous plus hydrogen gas. Clear? Clear or not? Next question is that you have to calculate the cell potential. Calculate the cell potential at 25 degrees Celsius or 298 Kelvin, where given concentration of H plus given 1 molar, concentration of Zn2 plus given 0.001 molar. Here, pressure of hydrogen given, pressure of hydrogen given 1 atmosphere, and E naught value of Zn to Zn2 plus, zinc to zinc 2 plus, oxidation value given 0.76 volt. Now calculate E naught of this cell. You can do or I'll do. Tell. You should try. I do. You should try. Okay, let's see. First one I'll go with. So see, oxidation potential given. So first we need to find out reduction potential. Yes or no? First we need to find out reduction potential. So what is the reduction potential? E naught zinc 2 plus 2 zinc. Reduction potential is minus 0.76 volt. Yes or no?
Yes.
So what is the E cell? E naught cell value. E naught cell value is equals to, we know, E of cathode minus E naught of anode. Yes or no?
Yes.
What is cathode? What is anode? That you need to understand first. This zinc 2 plus. Okay. Zinc to zinc 2 plus. This is oxidation. So oxidation means anode. So this will be act as an anode, and cathode is this H plus to H2. And this, what is the value of this E naught value? 0. So 0 minus, hello, 0 minus 0 minus minus of 0.76. So what is the E naught cell value? 0.76 volt. Clear this thing, understood or not?
Yes, sir.
E naught cell. First we calculate E naught cell. Next, what is the value of N? What is the value of N? Check. Zinc to Zn2 plus. How many electrons change? 2. So n equal to 2. Here how many electrons change? N equal to 2. So what is the value of n? 2. Clear? Now E cell. So E cell is equals to E cell equal to E naught cell minus 0.06 by n. N value is 2 log. Now listen. Product first will come product. So product concentration. So concentration of product zinc 2 plus into this is hydrogen gas. So into pressure of hydrogen gas divided by reactant concentration. So reactant concentration H plus. So H plus concentration square multiplied with zinc concentration, but zinc is solid, so we don't need to write or no need to check. So this is 1 only. So finally, just put the values. So 0.76 minus 0.03 log zinc 2 plus value is 0.001 means 10 power minus 3. Then this is 1, this is 1 square means 1. So finally we will get 0.76 plus 0.06. So finally it will be 0. How much? Sorry, 0.09 will come, right? So 0.85. Clear?
Yes, sir.
Understood or not? Tell.
Yes, sir.
Clear? Easy? Easy to calculate?
Yes,
Okay. Next. One more question. Let's
sir,
see.
we'll note down this number.
Huh? Understood how to do?
Yes,
So,
sir.
listen, one thing. I'm telling you one main thing. Main is if reaction given directly you can form this equation. Yes or no? If reaction given directly form this equation. Okay. If reaction not given, only cell representation given, you can write the reaction, then you can form. Okay. You can write the whole cell reaction, then you can form, or by seeing that also you can form. I'm coming into that. Okay.
Okay.
So for this reaction, let's suppose for this reaction, what is the cell reaction? Cell representation, zinc to zinc 2 plus. Okay. This H plus to H2. Yes or no? H plus to H2. Now, see, you need to understand product by reactant. So product is zinc 2 plus. Okay. And reactant is product is zinc 2 plus and hydrogen. And reactant is H plus. Remember which one is the left side? Always reactant. Okay. Left side ones are reactant. Now listen. This is oxidation and this is reduction. Okay. This is oxidation and this is reduction. Remember, always oxidation by reduction. So this is oxidation term, oxidation concentration divided by reduction concentration. Okay, by seeing the cell representation also you can do. Okay, but for that more practice you need. My suggestion in exam also, in board exam, you should write the reaction. That is the procedure actually. Directly you should not. MCQ you can do, but you should write the reaction. Then write this is oxidation. Okay, this is reduction. This is the n value. This is the given value, and then construct the Nernst equation. Write down according to Nernst equation. This A cell equal to E naught cell, and this. Then put the value. That's it. Okay, 3 mark question will come for this. Clear? Every year there will be an answer equation question from 3 mark. Okay.
Yes.
Next, one cell is given. Let's suppose Calculate E naught cell, E cell. Go ahead. I'm giving you 5 minutes. Time starts now. Nature of electrode, clear or not? Like if you change the electrode nature, okay, like zinc, instead of zinc, if you're taking copper, then the EMF value will change simply. Next, if you change the concentration, then also EMF value will change. Yes or no? Remember, always this thing remember, to spontaneous reaction, concentration of reactant will always be less than concentration of product will be always be less than concentration of reactant. Okay, for spontaneous reaction like this. Okay, so that you will understood by doing. You will see that product concentration. Spontaneous reaction concentration of product will be more than concentration of reactant. Like numerator will be more than denominator. Okay. Next, third factor is temperature. If you change the temperature, the E cell value will change. Clear? Clear or not? Now, so that thing, and from Nernst equation, you can say that the delta G naught and K equilibrium value you can understood. Like you know that at equilibrium, for example, a reaction is reactant to product. Okay, so at equilibrium, delta G value will be 0. Remember this thing, delta G value 0. Delta G naught value not equal to 0. Okay, and quotient become K equilibrium. Reaction quotient will become K equilibrium. So what will be the Nernst equation? 0 is equals to delta G naught plus 0 is equals to delta G naught plus RT ln K equilibrium. Yes or no? Yes. RT ln K equilibrium. So delta G naught is equals to minus RT ln K equilibrium. Okay. Delta G naught is equals to minus RT ln K equilibrium. Now, plus or minus, delta G naught equal to plus or minus? Plus. Plus, correct. Okay, minus RT ln K equilibrium. Now, delta G naught is equals to minus NFE cell, and RT means minus RT 2.3 log K equilibrium. Clear? Yes or no?
Yes.
Okay, so at 25 degrees Celsius, we can write at 25 degrees Celsius, we can write that E naught cell value will be is equals to 2.3 RT by NF log K equilibrium. Okay, or if you calculate, so 0.06 by 2 log K equilibrium. Clear? So by that we can find out the E cell. At equilibrium, we can find out the E cell value. Clear? So I'm giving a question. Let's see. Like silver solid is there, and it is dissociating into silver plus 1 electron. E naught cell value given, silver to silver plus. Okay, this value given, this reaction value given, minus 0.8. Next, this silver plus, when it react with NH3, it will give Ag NH3 whole 2 plus. Okay, this is actually known as Tollens reagent. Okay, aqueous, one kind of complex. Okay, and this for this reaction, Kf value given 10 power 6. Okay, Kf value given 10 power 6. You need to find out E naught cell. You need to find out E naught cell. Tell. Let's see who can tell what is the value of E naught cell. For Kf, here you can write K equilibrium, okay? K equilibrium value.
Or 0.1.
Hmm?
0.1.
0.18.
0.18.
0.18. How? Achha, this is what? This is what? Reduction or oxidation? This is what? Reduction or oxidation?
Oxidation.
Oxidation. Okay. Oxidation. And oxidation potential given. So what will be the reduction potential? E naught of Ag to Ag plus to Ag. That will be 0.8. Yes or no? That will be reduction potential 0.2J. Now NH3 to NH3 plus. This is oxidation actually. Yes or no? So first find out E naught value of NH3 to NH3 plus. So what is the value of NH3 to NH3 plus? So that is equals to this 0.06 divided by how many electron? One electron, one plus na. So one electron log K equilibrium 10 power 6. So is equals to 0.06 into 6 is equals to 0.36. 0.36 volt. So this is reduction, cathode, and this is oxidation, anode. Simply, we know that more value minus small value. So E cell is equals to 0.8 minus 0.36. This will be 0. E cell value 0. No, this will be 0. Plus will okay. So 0.36. So 1.16 will come. Okay, clear?
Yes.
Clear or not? How I am getting this? Tell, any idea? Why plus I wrote? Tell, why I wrote plus? No, right. E naught value you are calculating for oxidation, yes or no? So this value is for oxidation potential. You have to reverse it. So what is the reduction potential? E naught of reduction potential will be NH3, NH3 plus to NH3, yes or no? So reduction potential will be minus 0.36. So 0.8 minus or minus 0.36. So plus 1.16 volt. Clear?
Yes, sir.
Mm, okay. Okay. One question. Question is calculate Ag solid Ag plus 10 power minus 3 molar Ag plus 10 power minus 1 molar Ag solid. E cell value. E cell value you have to find out, and E naught cell value given 0. Why 0? Tell, why 0?
Because it is standard.
Because cathode E naught cell and anode E naught cell value same. Yes or no? Yes or no? Cathode inert cell and anode inert cell value same. So inert cell value 0. Now remember, if concentration also different, then also electricity can pass. Okay, so that's why cell is there. This kind of cell known as concentration cell. We'll talk about this. So find out E cell value. Go ahead. Let's see who can tell. Hmm,
0.118.
correct. So E is equals to 0 minus 0.06 divided by 1 log of oxidation by by reduction. Okay, or anode by cathode. Anode is this, so 10 power minus 3 divided by cathode is this, 10 power minus 1. Okay, so it will be 0.12. Clear?
Yes, sir.
Okay. Next topic. So there are some type of electrodes are there. Okay, type of electrodes are there. Like we talk about concentration electrode. So there are many type of electrodes. So one by one we will learn, and how to write, how to find the how to find the E cell value, that we will also check. So type of electrodes. First type of electrode is called a metal and metal ion electrode. Metal and metal ion electrode. So what is metal and metal ion electrode? It's very simple. That normal whatever electrode we are using. Okay, like you take a beaker. Hello.
Yes,
Yes.
sir.
Yeah. So what is metal and metal ion electrode? Simple. You take a beaker, and in that beaker you put an electrode. Okay. You put an electrode. Remember this electrode, what metal is there? That metal ion should be here. That electrolyte should have metal ion. Like if you use zinc, so this solution should be zinc 2 plus. Okay. Clear or not?
Yes, sir.
Okay. Metal ion N plus. Now let's suppose if this electrode, if you are using in anode, if you are using in anode, then anode means oxidation is there, so electrode will work as metal solid to metal N plus aqueous plus N electron. And how to represent that? Metal and metal N plus. Yes or no? And if you use is as cathode, then it will, there will be reduction. Reduction means metal N plus aqueous will get electron and it will become metal. Okay, how to represent metal N plus? Well, like this is salt bridge, this is salt bridge, metal N plus and metal. Clear? This thing understood?
Yes.
Now, next type of electrode is known as gas ion electrode. Gas ion electrode. Gas ion electrode. Now, very simple thing. Like electrode we will take as a gas. Okay, like this you take the electrolyte. Here you took the electrolyte. Okay, here you took the electrolyte, and as a electrode we have to take the gas. Now gas will not pass electricity, yes or no? Gas will not pass electricity. So for that we need to use one particular inert electrode. Okay, for that we need to use one inert electrode. So how to use that? See, this gas electrode is look like this. This here one hole is there, and like this is there, and one inert electrode will be attached in this electrolyte. Okay, and you will add the gas here. You will add the gas here. The gas will come here. In that inert electrode, the gas will deposit, and in this, that gaseous ion electrodes are there. Okay, hello, just hold a second. This gas ion electrode. So, am I audible?
Yes, sir.
Okay, talking about gas ion. So, we have to use this inert electrode. Understood? So, yeah, and in this solvent, what we use as electrolyte, either you can use water. Okay, and if you are using gas as hydrogen gas, so then you have to use HCl, like H plus ion should be there. Okay, H plus ion should be there. And inert electrode you should use as platinum. Inert electrode you should use as platinum. So what is gas ion electrode? In gas ion electrode, in gas ion electrode, generally inert metal, inert metal collector of electrons, inert metal which is a collector of electrons. Okay, like platinum or sometimes graphite. Okay, inert, they will not react with the gas. Okay, sometimes graphite means carbon. Okay, remain in contact with gas and its ions, in contact with gas and its ions. Clear? So if you take it as cathode, if you take this electrode as cathode, first as anode, let's suppose you take it as anode, then what will happen? Well, what will happen? Oxidation, right? So oxidation means whatever the gas, let's suppose hydrogen gas, will become H plus. Yes or no? Will become H plus. How to represent? See, electrode is platinum, so platinum solid. Next, what is it happening here? H2 become H plus. So H2 gas become H plus. Then salt bridge will come. Clear? This is how you have
Yes.
to represent. Now, as cathode, how you will represent? Similarly, just reverse. H plus will take the electron and half H2. So at cathode, how to represent? Simple. Salt bridge is there. H plus, H2 gaseous and platinum solid. Okay, that's it. Clear or not?
Yes, sir.
Yes, sir.
Next, this kind of cell we
So
are
in
doing.
gas electrode only hydrogen is possible, sir.
No, not only hydrogen. We can take other. Okay, we can take other oxygen also possible. Fluorine also possible. Okay,
Yes, sir.
so whatever the gases are there. Okay, so that we have to take generally. Next, is oxidation reduction cell. What we are using right now. Okay, what we are using for galvanic cell and all. Oxidation reduction cell. Okay, now oxidation reduction cell means what will happen? See, you take a beaker. In that beaker, two kind of ions are there. One is Fe3 plus and one is Fe2 plus. Both ions are there. Okay, Fe3 plus ions also there, Fe2 plus ions also there. Now, if you just put one inert electrode, inert electrode, okay, so it will show electricity. It will go the like electricity will pass out. So what is there? Oxidation reduction cell. That means in this half cell, and inert metal collector, inert metal collector of electrons like platinum remains dipped in remains dipped in a solution, dipped in a solution which contains which contains two ions of same element, two ions of same element in different oxidation state. Okay. So what is the condition? That in this case element should be same and it can show at least two different oxidation state. So if you take this electrode as anode, so as anode what will be the reaction? Tell. As anode what will be the reaction?
Oxidation.
What will be the reaction?
Fe2 plus to Fe3 plus.
Fe2 plus 2, Fe3 plus 1 electron. Remember, both are aqueous. Okay, both concentration you have to check when you are you have to take when you are using Nernst equation and all. And how to represent this? How to represent platinum solid? Then Fe2 plus to Fe3 plus. Then solid rich. And as cathode, if you take, then Fe3 plus to Fe2 plus, and here plus 1 electron. So how to represent? Fe2 plus, Fe3 plus, sorry, platinum. Clear? Clear or not?
Yes, sir.
Yes.
Okay. Next, today, last kind of electrode. There are many type of electrode we have to learn. Okay. Fourth type of electrode is concentration cell. It's kind of concentration cell electrode. Okay. Like last on silver one we did. So what is concentration cell? Concentration cell means when two half cell is there, and we are using two electrodes, and both the electrodes are same electrodes. Both the electrodes are same electrode. Okay. Both the electrodes same electrode. Let's suppose both are zinc. Anode also zinc, cathode also zinc. And the electrolyte we are using, that is also same. ZnSO4, ZnSO4. Okay. Zinc sulfate and zinc sulfate. Now this should have different concentration. This should have different concentration. Clear? So what is concentration cell? Concentration cell means, and because of this there will be a potential difference will be there. And you know potential difference is there. That means electricity will pass. So what is concentration cell? It consists of same type of electrons. It consists of same type of electrodes in cathodic as well as anodic compartment with different electrolyte concentration. Different with same electrolyte but different concentration. Electrolyte but different concentration. Understood?
Yes, sir.
Okay. So potential see two remember this thing, potential difference possible to two possibilities there. Either concentration difference is there or pressure difference is there. Okay. Pressure difference is there. I'll give you two example on this. First is concentration difference. So what is the first concentration difference? Like zinc solid is there, they become zinc 2 plus. Okay. So this have C1 concentration and zinc 2 plus. This is C2 concentration and zinc. Clear? So for this, what will be the E cell value? E cell is equals to E naught cell minus 0.059, or you can say directly, I'm not taking that value, 2.3 RT by NF. Yes or no? Log of, tell me, C1 by C2 or C2 by C1?
C1 by C2.
C1 by C2. Oxidation anode by cathode. Yes or no? So C1 by C2. Clear or not?
Yes, sir.
Achha, tell me, when this cell will work, when this cell will work, tell.
When there is different concentration and
That I understood. Different concentration is there. But when this cell will work, when the electron will go from this side to this side,
Potential difference.
when it will possible by seeing this equation, tell me when this is possible. When only and only when C2 greater than C1, yes or no? If C2 greater than C1, listen, if C2 greater than C1, then C1 by C2 value always less than 1, yes or no?
Yes.
If C1 by C2 value less than 1, let's suppose 10 power minus 1. So if 10 power minus 1, so this whole value will become positive, yes or no?
yes.
So if whole value become positive, E cell value also become positive, and you know E cell positive means delta G negative, yes or no?
Yes.
So E cell value delta. So always remember concentration cell when it will work when C2 more than C1, or reduction or cathode concentration will be more than anode concentration. Remember this thing. Clear?
Yes.
Next, next, when in case of gas, in case of difference in pressure, let's suppose platinum is there, solid, okay, hydrogen, 1 atmosphere given, and H plus aqueous solution given, okay, and another hydrogen electrode you take this side. Both concentration can be same, but if I change 5 atmosphere, then platinum solid, then there will be E cell we will get. So E cell is equals to, what will be the E naught cell value? 0, yes or no? Minus
Yes, sir.
0.06 by N log. Now tell me, what will be 5 by 1 or 1 by 5?
5.
L. 5 by 1 or 1 by 5? Let's
What
see.
is 5?
1 by 5.
Absolutely wrong answer. What I told, this is reactant, this is product, this is reactant, this is product, yes or no? Yes or no? Here also this is reactant, this is product, this is reactant, this is product. That's why you do the product by reactant, yes or no?
Yes, sir.
Here also product by reactant, so product by reactant, so 5 by 1. Clear? Yes or no? Yes or no? Understood? So
Yes, sir.
for this we will get minus 0.06 by N log 5. Now you understood which one should be more? Okay, clear? So this is not possible. So that's why reverse one is possible. Clear or not? Tell.
Yes, sir.
Yes, sir.
Okay, so let's end with one question. Question is, calculate equilibrium constant for the reaction iron plus cadmium 2 plus aqueous is in equilibrium with iron 2 plus aqueous plus cadmium solid. E naught value of cadmium 2 plus to cadmium is given minus 0.4 volt, and E naught value of Fe2 plus to Fe is given minus 0.44 volt. Calculate K equilibrium. Simple, very simple question. Go ahead. I'm giving you 5 minutes. Go ahead. So E cell is equals to, we know E naught cell. So E naught minus 0.06. What is the N value? 2 log K equilibrium. Yes or no? So E naught cell is equals to 0.06 by 2 log K. So what is the E naught cell value? Cathode minus anode or high minus low? Yes or no? So high minus low. Am I correct? No, wrong. This is the high. Okay. This is the high value. So E naught cell value will be minus 0.4 minus of minus 0.44. So 0.04. Okay, that is the E naught cell value. So E naught is equals to 0.04 is equals to 0.03 log K. So log K is equals to 0.04 by 0.03, or you can write 4 by 3. So K is equals to 10 power 4 by 3. Yes or no?
Yes, sir.
Okay, now 10 power 4 by 3, what is the value that you need to understand? It should be more than 10. Okay,
Yes.
understood how to do?
Yes.
Yes, sir.
So
Tell me.
that till log K is equal to 4 by 3 I got. After that, by shifting log, that will become
Array, again, you told only log you know. Achha, log 10 means 1. Yes or no?
yes, sir.
Log 10 means 1. Achha, can I write 10 equal to 10 power 1? Hey, sorry.
Yes,
Log 10, 10 equal to 10 power 1. Achha, log 10 square means 2. Can I write 10 equal to, 10 square? This side 10 square means this side 10 square. Yes or no?
yes, sir.
That's it. Simple.
Okay, sir.
Clear. Whatever the value, that will be to the base. Now, if log 2 base 2 is there, then 2 power 4 by 3. Okay, that you need to check. That's why the log
Okay.
base 10 is there. So 10 power 4 by 3, whatever the value. Or else what if
10 power 4 by 3 and
see, both side you take log. So this side you take log K. This side you take log. So log 10 power 4 by 3. So 4 by 3 will come. Understood?
yes, sir.
That's it. Okay. So practice the, see, nothing you have to go. Just practice the NCERT question. Just practice the NCERT questions. I'm showing you. I'll send some questions also. Okay. Just practice the NCERT question.